active distribution partners for Spectralink in Australia and New Zealand. My name is Chris Pulsford. I'm the National Partner Enablement Manager for Wavelink. Some key points just to mention before we jump into the configuration demonstration. The Spectralink IP DECT solution utilises SIP extensions, so any PBX or call server that supports standards-based SIP extensions is a good fit for interoperability with the Spectralink IP DECT solution. The base stations and also the IP DECT Server 400 utilise PoE or Power over Ethernet on the customer's network on the 802.3AF standard, so if the customer has standards-based PoE switches, then they can power the DECT infrastructure via those switches. Protocols we'll be looking at are HTTP and HTTPS, and we'll be using those to configure the solution via the web browser administration portal, and also Simple Network Management Protocol and syslog. The systems do support encryption of all traffic via an optional software license, so we can encrypt both the SIP control traffic and the RTP audio traffic as well. If we had a security conscious environment, we can certainly provide full encryption and security. Microsoft certified Spectralink IP DECT solutions for use with Microsoft Link, which we can see on Microsoft TechNet interoperability documentation, and also Cisco has certified it for the Cisco Unified Communications Manager. So really any SIP standard-based IP PBX or call server, however, will be a good fit for the solution. For the configuration demonstration today, we'll be configuring a Spectralink IP DECT Server 400 and a Spectralink IP DECT base station, as well as a couple of Spectralink DECT handsets. So I'll now flick over to our configuration, and I just want to start by pointing out that we're using a Digium Switchbox call server or IP PBX for our interoperability, and we've got a number of SIP extensions you can see here starting at number 100, and we'll be using a couple of those for configuring with the DECT solution, so we can have a couple of DECT handsets as SIP extensions on this call server. So I'm now going to log into the Spectralink IP DECT Server 400 interface via its default IP address, and on the general status page here we can see some specific information to this particular system, as well as some hardware and firmware information and some quick status information showing us status information about the interoperability and the other network components that we're working with here. Obviously, not having configured the system yet, we don't have any positive status information. So I'll start by jumping into the configuration here, and under the configuration tab we'll go into the general tab, and we can see here that by default the system is DHCP, and essentially what happens is in its default state when you connect the DECT solution into the network, it will do a DHCP discover and look for the DHCP server. If it doesn't get a response within a short period of time, then it will revert to its default IP address 192.168.0.1. So what I'll start by doing is changing that to a static address, which we should always do with network servers, and I'll put that on the same subnet as the call server. We can see here that IP version 6 is also supported, as is VLAN tag, and you can also see if we hover our pointer over the various settings we can get a description or a helper file. So I'll also set the DNS server as well. And although I don't have an NTP server on my network here or internet access, I'll also set an NTP server. So it's important to have time synchronization for both the handsets to show correct date and time information, and more importantly for administrators to have correct timestamps on all the logs and statistics. Here's where I'd set up a remote syslog server connection, and here's where I'd set up SNMP connectivity. So if I wanted to run SNMP to monitor this server, I can download the management information base from Spectralink's support portal. So I'm going to save those parameters here. Being that we've just changed some system IP parameters, we'll be prompted to reboot the system to apply those. So if I go and just run a ping to that solution here, we'll that it'll soon time out on that old IP address as it applies the new settings and goes through a reboot phase. So once that reboot's complete, we'll be able to then log back into the DECT server on its new IP address, which is 10.225.15.103. So we make sure that it's talking to the subnet where you can access the call server. So we'll just start the ping new address there. So we can see when that comes up. Okay, so it's responding. So what I'll do is now log back in on its new address. And there we go. So the next thing I'll configure is the SIP global settings. So again, under our configuration menu, we go to the SIP tab. These are our SIP global settings. So essentially what I'm doing here is configuring the system to work correctly with the call server. So I'm just going to use the SIP default port, which is what the switch box uses, and leave the transport type as UDP, although you can see it's also supporting TCP and TLS. I'll set my default domain to either the host name or IP address of the call server. These other settings can be changed if required by the call server to ensure correct interoperation. I'm also going to set my proxy, my first proxy at least, to the call server, which would be typical for an on-site PBX. Now, if we had a hosted cloud PBX, then we could set additional proxies as provided by the hosting provider. Or let's say we were running a multi-site scenario where we might have a call manager, let's say a Cisco call manager at head office, and we're deploying this IP DECT solution at one of the branch offices, then we can set our call manager address as our first proxy, and if we had SRST capability for redundancy, I could set, let's say, the Cisco router as an additional proxy here, and that would give me option to have the system still access local lines for inbound and outbound calls in the event that the link to the head office wasn't available. Authentication can be done globally, although best practice would be to do that on a per user basis, which is what we'll do. I can change the DTMF signaling, dual tone multiple frequency if I need to. The DTMF mode by default is RFC 2833 or in-band, so the DTMF gets sent through an RTP stream separate to the voice RTP stream. Also supports SIP info. MWI settings to make sure when I've got a voicemail in my voicemail box, I'll see that on the screen of my phone through the MWI. I can change the media parameters, so this would be for the audio component of the call, voice stream, running over RTP, so I can change things like my packetization interval here, I can change my port range, I can change the codec priority list, which I'll do. I'll set PCMA, G711A or ALAW as my first priority, PCMU or G711U or ULAW as the second priority, and we'll put G729, the compressed codec, as our third priority. So these parameters here are what will be negotiated with the call setup in the session description protocol or SDP, which we can see if we do a packet capture and look at the SIP and SDP. And we've got additional settings here as well, which we can change if required for correct interoperation, but that's all we're going to do here. So I'll save those settings. Again, I can do a system reboot here. Before I do that, what I'll actually do is load up a license as well, because we want to add additional base stations. So by default, the IP DECT server 400 is what's called a single cell DECT solution, which means there is only one base station, and that is, in the case of the 400, the DECT server and base station in one. So while I can add repeaters in a single cell state, that would give me additional coverage, but not additional channels for voice calls. So if I do have the requirement to add additional base stations, then I can enable that to become a multi-cell solution by adding a license. So I'll go to my administration menu here, and I'll go to license, and I've got a software license key here to enable multi-cell. I'll copy that, paste that in here, load that up. We can see our DHCP option 66 in your DHCP scope to set the boot server, which will be set to the device along with the IP parameters. So when the device applies the IP parameters, it will then look for a boot server, for example a TFTP server, where it would look for a configuration file which we could have there waiting, and the system would then download the configuration file and apply parameters for that. We can do that for the configuration, we can do that for the users, we can push a firmware file for a firmware update from a provisioning server there. So if you wanted to have a look at where we get a baseline template for our configuration, we could export the configuration file from the DECT server. Just quickly do that, we'll open that up and have a look. So I'll open that up in my XML editing tool here. We can see parameters that have been configured. So that's another option we have for configuring the system there. Okay, so we'll do a reboot now of our system since we've applied the license key and made some SIP parameter changes as well. Okay, so the system is now rebooting. While the system is rebooting, I'll just jump back to the presentation for a moment. An important part of any configuration or DECT deployment is the site survey. So this is how we work out that we get the correct signal coverage for the users to make and receive phone calls within the required coverage area, and also the location and number of DECT radios we need to deploy, which could be base stations, it could be repeaters, or a mixture of both. So the success or failure of a DECT deployment relies very heavily on starting out with the site survey and doing that correctly. So we can do that using a Spectralink DECT handset. In fact, it's always best to use two. We could take our deployment kit to site, which might have, let's say, a IP DECT server 400 powered on the PoE battery, and we can set up a couple of phones on that which can call each other directly without a call server connected, since they can do a loopback mode. And we can then have a call between the two handsets, and we can also put them in site survey mode by entering a star code into the handset keypad, which will then basically prompt the handset to display information about both the signal quality and signal strength as seen by the handset from the base station. And then we can walk around our site, and with the site plan we can make markings of the coverage patterns. It's really important with a IP DECT solution and IP base stations to make sure we get a 50% overlap between our base stations. So essentially what we do is put our base station down, we then walk around the floor, and we mark on our map the signal boundary, or the acceptable signal boundary from that base station, which will rely on both the signal quality and signal strength readings shown on the handset site survey mode. We would then know that we need to put our adjacent base station on the line of acceptable signal boundary to make sure we get that 50% overlap, and that will facilitate a user walking through the environment while they're on a call, and their handset having enough time to hand over correctly from one base station to the next, and still ensuring uninterrupted call quality for the user of the handset. So again, really important to make sure we get our 50% overlap when we're using IP DECT, because the base stations will synchronise to each other over the air, whereas with traditional DECT and digital base stations, that synchronisation is done over the wire. Another reason that's really important is because that over-the-air synchronisation is used to build what we call a synchronisation chain, in which one of the IP base stations will be the master base station, and the other IP base stations will essentially use that master base station as their synchronisation master, and they'll either directly connect to the synchronisation master over the air, or they'll connect by intermediate base stations to the master base stations over the air. So we want to deploy our master base station as centrally as possible, and make sure that our other base stations are placed in proximity that gives them that 50% overlap. So looking at a site plan here, we can see the base stations marked with a square with a cross in there, and we can see that the line surrounding the base station actually touches on or overlaps with the adjacent base station. That's how we get our 50% overlap. so that is extremely critical. Then we can see some additional reading points on the floor where a handset inside survey mode has looked at both the signal quality and signal strength that it sees to the adjacent base station, and that's essentially how we do our site survey and plan out and build our sync chains to make sure we have that correct operation. Okay, so at this point I'll jump back to our DECT server 400 and we can verify that our license has been applied. Okay, so we can see our license key here, which unlocks the multi-cell functionality. So I've also plugged in a IP base station, which would access on its default address. Okay, so we can see there the interface for the IP base station looks quite similar to the DECT server, however there is less options and less settings in there that we can configure. So what we want to do is, first of all, start by setting a static IP address on the same subnet as the DECT server. So we'll make this 203. Save that. And secondly, we want to point base station at the DECT server so they can synchronize. Okay, so we'll reboot at the base station, and essentially that's the only configuration we need to do directly on the base station. All the other configuration in terms of our sync chains we can configure via the DECT server itself. And when that base station is finished rebooting, we'll see, in addition to RPN or radio part number 0, which is the DECT server itself, as we said that's also a base, we'll see the additional base station come up in this list. Okay, well, while we're waiting for that to happen, we'll proceed to the next step, which is configuring a DECT user. So I'm going to users menu here, and I'm going to configure a DECT user. Now what we can see here is the system ARI, and it's the access rights identifier, and that's essentially the unique serial number, if you like, that the DECT server broadcasts over the RF, and that's how the handset can locate the DECT server, and with the correct configuration can subscribe to the DECT server. So we'll create a new user here, and we need to enter the IPI or IP number, which is the International Parts and Equipment Identifier. It's essentially like the ARI is for the DECT server, is the unique serial number for the handset. So I've got here a Spectralink DECT 7620 handset, and I basically show you where we can get the IPI number. Now you can see a sticker on the back, and it's located there, though you may not be able to see that on the webcam. So I'll also go in through the menu. If we go into our handset menu here, and we scroll to the status option, general information, we can see our IPI number there. Okay, so I'm going to take that number and I'm going to input it into the server here. In fact, there's already in there since I've used it before. And I'm not going to use an access code. Now, an access code could provide an additional layer of security when subscribing handsets, because the person subscribing to handsets would need to know the access code in the server. The other reason we could use that is if we're using a third-party handset, such as let's say a Siemens handset, which supports the GAP standard, as does the Spectralink gear, which means generic access protocol, and allows handsets from one vendor to interoperate with infrastructure from the second vendor, or vice versa. The Siemens handsets, for example, would use a 40 access code, so we can enter that into the into the DECT server here to ensure interoperability. However, since we're using a Spectralink DECT handset on a Spectralink DECT server, I won't be doing that. Standby text is what the user will see on the screen. Now we're going to configure this handset to be extension 101 on the call server, so I'll set that to 101. SIP username or extension number will be 101. Now the domain would be the host name or IP address of the call server, but since we've already defined that global SIP configuration, we don't need to do that again. The display name is what will be set with the SIP invite during a call setup. The authentication user has to be the same as the extension number setting up here, so we'll make that 101 as well. And then the authentication password needs to match that on the SIP extension on the PBX. So there'll be an authentication process, so we need to make sure we get the username and password correct there. We'll save that. Now we can see straight away we've got a SIP registration back to the call server. So the SIP registration is actually held on the DECT server, not on the DECT handset. The DECT handset doesn't talk SIP, it purely talks proprietary digital protocol to the DECT base station and onto the DECT server, but it's the DECT server which does the SIP on the other side onto the wide network and to the SIP server or IP PBX in this case. So we've already got a SIP registration, although our handset is not subscribed, which is related to the handset talking to the DECT server via the base station. So the next step will be to subscribe the handset so it's talking to the DECT server, and I'll show you that on the webcam there. So we need to go to our settings menu and we'll scroll to our advanced settings. Then we'll go login. Create login. Now what's happening here is the handset is scanning the RF and it's looking for DECT servers in the air. So in my environment here I've got a number of DECT servers. The numbers that you'll see there are the ARIs, the unique numbers for each of those DECT servers. Now we can see on our web page there that our system ARI is 704, so there it is there. So I'm going to scroll to that, I'm going to select that. Since I left the access code blank, I'll just hit OK. You can see a connection being established there. So connection OK. So that handset is now subscribed. If I go back to my web page here and refresh it, you should see a tick under the subscription there as well. Okay, so that handset's good to go. Now another option to configure a user would be to import a user config. So for the second user, we'll actually import a CSV file here, and we can see I've got a users.csv, and we can see the parameters there, essentially the same as we put into the web browser for the first user. And so I'm going to open that user file, load it up. So one user imported successfully, and if we go back to our users list, see now we have the second user, we've got our SIP registration active again, so we now need to subscribe the handset. So we'll do that with our Spectralink 7740 handset here. So we'll go through the settings, advanced settings, login, create login, and again the handset will scan the RF looking for the various DECT solutions it can see. We need to find our ARI at 704, there we go. So we'll select that. Again, we don't have an access code, so it's connecting. Okay, so we've got a connection. If I go back to the web page here and refresh that, we can now see we've got two subscribed handsets, and we can see also the NWI or message waiting indication on the screen, which indicates that there are voicemails on extension 102 on the PBX, so the handset user can see that. And we could also at this stage make a phone call from 101 to 102 just to verify that we've got functionality there. So if I answer that call, you can see we're connected. And I could also go into the statistics here, go to active calls. We can see that we've got an active call listed on the system. Okay, so we've got our handsets up and running now. Yeah, we'll go back to our base station, which should have rebooted by now. Okay, so we can see we've got our second base station here, RPN number 1, and we can see that it is synchronized. So as we said, we'd always need one master base to handle the synchronization, and being the first base on the network and also the server, the DECT 400 has assumed the role as free running, or the master base station, the synchronization master. So it synchronizes to itself, which is 0, and then the second base, which is RPN 1, is also synchronizing over the air back to 0. The sync master. The reason we can see 0/0 is we can have an alternative sync master, so a primary sync master and an alternative sync master. If we can see multiple base stations from that base station, then we have the option to set an alternative sync master for redundancy. But since we've only got one other base station we can sync to, we're going to use that for both our primary and our secondary sync source. If I go into the base station 400 here, I can see also the setting or the signal strength that that base sees to the other bases. In this case we've only got one other base, but that's another way that I can build a sync chain, is by not only looking at the floor plan and seeing surrounding bases based on the floor plan, I can also use this information here to make sure I'm setting up my sync chain correctly. Okay, so we now have our additional base station up and running. We've got 2 DECT users. Let's have a look how we can put the phone book onto the system, a global phone book. So under administration again, if we go into the phone book, we can have a couple of options setting a global phone book. So we can also load a phone book direct to a handset. That's it's not the most efficient way to do it, so it's much better if we can set a global phone book. So I can either import a CSV file, which I'll do now. And you can see here I've just got a CSV file with essentially 4 fields. The first being the user, or the contact, the phone book contact, and then I've got 3 other fields here. 1 is their extension number, 2 is their mobile number, 3 is their landline number. So I've got 3 dialable number fields for each user. And as a result, I'm going to specify those number fields for dialable numbers here, 2, 3 and 4, and then I'll open up the phone book. Phone book configuration saved. Okay, so let's have a look at how that would appear on our handset. So if I put the handset back up there. Okay, we can see our phone book, and we can navigate between the users. I could hit the dial key at that point to dial their extension number, or I could go further into that contact and I can access all the dialable numbers there. It's a nice easy way to do a global phone book. Also we can see we've got an option to set it up to use LDAP for its phone book. We can point it at our LDAP server and it will take the phone book direct from LDAP. So another option there for global phone book. Okay, so just before we finish up, let's have a look at the logs. So we can see our log here. Now, unfortunately, since I don't have an NTP server configured or reachable, I don't have accurate timestamps on our logs here, but we can see some of the information that appears in the logs. So we'll see errors about the time server since we did set one, but we can't access one. We can see things like the handsets registering, users being imported, etc. And we can see information regarding to the phone books that we set up as well. Additional useful information for administrators, we can do a packet capture, so we can take a packet capture of everything or various types of traffic straight off the DECT server. We can open that PCAP up, Wireshark to do some analysis. We can do some network diagnostics with ping and trace route options. And also under statistics, we can see some statistics related to the activity on the system, so wireless server, media resources, base stations, etc. Obviously there's not a lot of activity since we've just configured the system. However, on an active system, this is a really useful resource to understand how the system's functioning and potentially if there's some issues being reported to start troubleshooting and looking for some potential reasons for that. Okay, so we've now got a fully configured system, so let's finish off by doing a configuration backup. So if we go into administration and backup, we can simply do a full system backup there and download that as a tar file. We can restore that if and when we need to. On a final note, there's an excellent support portal from Spectralink, which is located at support.spectralink.com, and that's got a wealth of resources for both administrators and users. So certainly suggest, if you're working with these products, you have a look at the support portal as a starting point for any of your documentation or technical needs. Thanks for attending the webinar. This has been brought to you by